So for this unit, what we're doing is distribution and normal curves, which is basically a lot of stats. So if you're taking pop stat next year, this will be a little preview of it. Everything we do today, you do have to study some things, especially these numbers, because if not, you'll be super confused on what the numbers mean. And that's a large part of the lesson. All right, so a distribution is a set of data and their frequency of occurrence. You guys have used data before. Normally it was like in elementary school or middle school. You had the mean, median, and mode. It's a little different, so now we're taking it a little bit further. So distributions have three important values associated with them. The mean is your average value. Okay, the mean is your average. You will have two symbols for that. Your first symbol is a symbol called a mu. It just looks like a fancy N with like a long tail. You'll see that a lot today. And then in your calculator, the mean is an X with a line on top of it. That is very important. So you can find it in your calculator. It's an X with a line on top. Your median is the middle value. Oh, okay, he's not here, but I'll give it to his son.
Thank you.
Thank you. Alright, so your symbol for median is going to be a capital M, or actually the words MED. And then standard deviation, which is a lot of what we're doing today, is the average distance from the mean. It's the average distance from the mean. And your symbol for standard deviation is like a circle with a long tail, or a sideways V. Alright, so here we have the calculator tricks. This basically just tells you how to do it. Okay, we've already put data into our calculator before by hitting stat edit and putting it into our L1, so we're going to do that. And then we'll talk about how to find all these numbers. Look at this part. It says find the mean, median, and standard deviation for each set of data. So we need the mean, the median, and then standard deviation. All right, so everyone grab your calculators. I want you guys to actually put this in so you can know how to do it. All right. Kelly with us. All right, so let's hit stat. And then enter for edit. And you should have L1, L2, L3. Make sure your L1 is clear. If it's not, you're going to scroll up, hit the word clear, and then scroll back down and it'll all disappear. Do not hit the word delete. If you hit delete, it's going to take away that entire column, and you don't want to do that. All right, you guys have your L1? All right, let's type these numbers in. And because we have decimals, be careful, because I know I go too fast, and Like 19.9, I could put 19.0 and that could just mess everything up. So make sure you double check your numbers. So we have 18.9, 19.9, 14.2, 20.3, 5.9. What's after 5.9, guys? 8.5. What's next? 16. Okay.
18.1.
18.1. And then like 4 or something. All right, thank you. You should have 9 numbers. So if you count them, it says 10 there for your next number, but you should have 9 that are already completed. All right, once you have your numbers in, we're going to hit Stat. Scroll over to Calc. And we need our first VAR stats. So that's our one variable stats. Basically that L1. Okay, so they're giving us a lot of information here. We actually don't need all this information, okay? We actually haven't even learned what most of these symbols mean. But do you recognize the mean? It's the first one, okay? That's our symbol for mean. So our mean is 14.01. And the mean is 14.01. To find the median, you see this arrow? It tells me I can scroll down. So my median is there. It says MED. Okay, so my median is 16.2. Okay. And in your calculator, like your symbol for standard deviation is this. But in your calculator, they always put an X beside it. So let's look in your calculator. There we go right there. This has like a little sideways B and then an X. That's your standard deviation. So 5.91. Okay. So this is how you find this. When you guys were younger, you had to find mean, median, and mode. You guys remember having to put them in order from least to greatest first before you could do anything? Your calculator basically does all this for you, okay? And it's also calculating your standard deviation, which we could learn how to do, but it would take us much longer. All right, you guys do number 2. And let me know what you get. All right, what'd you get for your mean? What'd you get? 9.62? All right, what about for your median? And then your standard deviation. Good. Did you guys have those numbers? Yeah, okay, good. All right, so this part is very important. It's your normal distribution. The normal bell curve represents a normal distribution. That word normal just means that everything's going to be even. The total probability under the curve is 100%. So half on each side of the mean. The mean of a normal distribution is at 0, and the standard deviation is 1. So when given a set of data that is normally distributed, the mean is the center of the bell curve. That's your average. That is the center of the bell curve. And the standard deviation, you can abbreviate it if you want it, but I'm going to write it out. The standard deviation is counted from the mean, 1 in each direction. So number 1, it says for a math class, the average score on the test was 82, and the standard deviation of the normally distributed scores was 5. Sketch a normal curve showing the test scores and 3 standard deviations from the mean. The reason why I handed you guys highlighters is because you can highlight things that are important. There are some things you need to know. You need to know that the average score of the test was 82. You also need to know that the standard deviation was 5. So what they're asking us to do is to sketch a normal curve showing the test scores and 3 standard deviations from the mean. A rule of thumb is that we always have 3 standard deviations from the mean. Always, always, always. So what we do first is we draw a line right down the middle. Right down the middle is our mean. What did they tell us our mean was? What's the average? 82. Okay, so that means if I had 3 deviations on each side, that's 1, 2, 3. My bell curve is a little off, so try to ignore the small notches kind of above the line. But draw 3 lines on each side, because we always have 3 standard deviations on each side. So my deviation is 5, so that means when I fill this in, each score has to have a difference of 5. So if we go to the left, we're going backwards, so we're going to subtract 5. Okay, so that means that this is 1 standard deviation, sorry, -1. This is -2 standard deviations, and this is -3 standard deviations. On this side, this would be 1 deviation, 2 deviation, and then 3 standard deviations. Thank you. All right, so that's really important. You need to know what we mean when we say 1 to 2 or 3 standard deviations. That means according to the mean. This is 1 spot over, this is 2, and that's 3. So if we are talking about filling out this whole curve, what's 82 minus 5?
7.
Okay, so -1 deviation is 77. All right, minus 5 again. 72. Minus 5 again. 67. All right, let's go to the right. I'm going to be adding 5. So 82 plus 5?
27.
Plus 5. And plus 5 again. Good. So now I have a deviation of 5 in between each number. We always start with the mean. Okay, for that one, that's all we had to do. That's all they're showing us. For number 2, it says the scores on the last quiz follow a normal distribution. The average is 29, that's important. The average is 29, and the standard deviation is 3. What is the range of the scores that lie within 1 standard deviation from the mean? So let's fill in what we know. My average is what? My average is 29. That goes right in the middle. I want how many deviations on each side? Always 3. So I'm going to draw my lines. 1, 2, 3. 1, 2, 3. Ignore the small bell curve. All right, so my deviation is 3. So -1 deviation from the mean would be what? What's 29 minus 3? This is 26 minus 3. And minus 3 again gives me 20. I go the other way and I add 3. I have 32, 35, and 38. So they're asking for 1 standard deviation from the mean. If I'm going 1 standard deviation from the mean, what do I need here? What are my numbers? 26 and 32. Because 1 standard deviation away from the mean would be all of this. So my answer is B, 26 to 32. Any questions there? All right, the empirical rules, what I was talking about, you guys have to absolutely study. The empirical rule is known as the 68, 95, and 99.7 rule. You need to know those three numbers. Basically, it states that for a normal curve, we can assume that most of the data, which is 99.7, will fall between 3 standard deviations from the mean. All right, so let's look at this curve here. My mean goes right down the middle. Okay, this is my mean. I know you guys don't have much space underneath, just try to make it work, or you can write on the picture. All right, if we go 1 standard deviation away from the mean, so that's -1 and +1, this together is 68% of our data. So 68% of our data points will fall within 1 standard deviation of the mean. If I go 2 standard deviations away from the mean, that represents 95% of my data. And then if I go 3 deviations from the mean, that represents 99.7. So those are your magic numbers. Here's an example. On the last Algebra 2 test, student scores represented a normal curve. After analyzing the test results, we found that the mean was 80% and the standard deviation was 5. So part A says label the normal curve based on the data provided. Alright, so my mean is right in the middle. And my mean is 80. If I have 3 standard deviations on each side, what's my standard deviation here? What did they tell us it was? Yes, are you getting this or are you just lost? Yeah. But stop. Is everyone getting this, or are you guys just lost? Or are you lost? This tells you the difference between each deviation we're going to go. Okay? So if my deviation is 5, that means that when I go backwards, this is 75, this is 70, and this is 65. If I go to the right, this is 85. This is 90, and this is 95. Does that make sense, Quincy? Okay. So 68% of students score between what? So 68% is how many deviations from the mean? It's 1 deviation away. So if I'm looking at 1 deviation away, this is 68%. So the students score between what? 75 and 85. So 95% of students score between, this is 2 deviations. What did they score between two deviations? 70 and 90. Because we're going from here to there. And the last one is 3 deviations away from the mean because it's 99.7% of students, which is 65 and 95. Everything is based on the mean. Any questions there? All right, we can use the empirical rule to break down the normal curve even more because normal curves are symmetrical. So if normal curves are symmetrical, right down the middle, it's going to be our mean. We've already decided that 1 deviation away is how many percent? 16%. So if I want to split that in half, it becomes what? Like what is each piece worth if the whole thing is 68? $34. So this is 34, and this is 34%. Two deviations away, you know, is 95%. So if I want to figure out what both of these small pieces are, so I'm going to type in 95 minus 68.
27.
All right, now divide by 2.
13.5.
All right, so that means that this guy right here is 13.5%, and this one right here is 13.5%. All we're doing is just breaking it down even further. And then if I'm 3 deviations away, that's 99.7. But if I want to figure out what these individual pieces are, what's 99.7 minus 95? We're just going to take away what's on the inside.
4.7.
What is it?
4.7.
All right, divide by 2.
2.35.
So that means that this is 2.35%, and this piece is 2.35%. Okay, and even though we let it go out 3 deviations, if we did the full thing, which is 100%, what's 100 minus 99.7? Divide by 2.
13.
So that means that this small piece over here is 0.15%, and this over here is 0.15%. You guys absolutely have to memorize everything on this page. As long as you know your 68, 95, and 99.7, you can figure it out by subtracting the previous number and dividing by 2. But you will need to know what each piece is worth. I always start in the middle. If I start in the middle where my mean is, I know these are each 34, and then 13.5, and then 2.35, and then 0.15. So if you just kind of start it in the middle and you learn a half of it, they're symmetrical. Do you guys have this next? But I messed up this. Okay. So applying this to our example. So here we only have 3 deviations from the mean, which is good. Here's my mean. All right, so what percentage of students score between 85 and 90? So what percentage of students scored here between 85 and 90%? 13.5%. So it doesn't matter what our numbers are, we know that 13.5% is represented by this space here because the middle two are both 34. All right, so then it says what percentage of students score below 75%? So that means this whole area in this area. This first area is what? Between 75 and 70% is what? 13.5. And then this bottom area is what? Nope, not quite. What's right after 13.5? 2.35. If they kept going out a little bit further, then this would be 0.15. Okay. All right, so what percentage of students score below 75%? I'm going to add 13.5 plus 2.35. And what do you get? 15.85%. And the last question says, what percentage of students scored higher than 85%? So higher than 85% would be this area and this area. 15.85 because we're adding the first part, which is 13.5, and the second part, which is 2.35. So you get the same answer. 15.85%. All right, so we're going to do the practice together. I want you guys to at least start with number 1. Number 1 says, which description of the normal distribution is most likely not true? What did you guys get for this one? You should get D. Because they're asking for which one is not true. And the first one says that approximately 99.7% of the data will fall within 3 standard deviations of the mean. That's correct, but we need what is not correct. B says 95% of the data will fall within 2. That is also correct. And C says approximately 68% of the data will fall within 1 standard deviation. That is correct too. So D is the best answer because approximately 34% of the data does not fall within 1 standard deviation. 3 deviations are on both sides. That will be half. All right, so a normal distribution of data has a mean of 0 and a standard deviation of 0.75. What percent of the data will be expected to be between negative 1.5 and 1.5? All right, so you have to draw your curve. Do not think that you can do it in your head. I'm telling you, it does not work that way. Your curve doesn't have to be perfect. Try to make it like a little hump. Alright, right down the middle is my mean. What is my mean on this problem? My mean is 0. I need how many deviations on each side? Always. 3 on each side. 1, 2, 3. 1, 2, 3. Alright, and my standard deviation is 0.75. So if I fill in these numbers, if I go to the left, 0 minus 0.75 is negative 0.75. And then if I minus 0.75 again, I get negative 1.5. And then again, I get negative 2.25. On the other side, 0 plus my deviation is 0.75, 1.5, and 2.25. So it says what percent of the data would be expected to be between negative 1.5, which is here, and 1.5, which is there. So I need all of this. So if I'm 2 standard deviations away from the mean, what percent of data is this? We're 2 deviations away. What did you say? Huh? Yeah, 95. So because we are 2 standard deviations away from the mean, that is 95%. We could break it down if you wanted to and do 13.5 plus 34 plus 34 plus 13.5. But that's a little bit more work instead of just learning that 2 deviations away is 95%. All right, the number of hours that students studied for their Unit 6 test is going to be distributed. Of the 90 students surveyed, the mean number of hours they studied was 5 hours, and the standard deviation was a half hour. Of the 90 students surveyed, what percentage of the students studied 6 hours or more? So let's draw your curve. What was my mean here? My mean was 5. I need 3 deviations on each side. And my deviation was a half hour. So that means I have 4.5, 4, 3.5. The other side I have 5.5, 6, and 6.5. It says, what percentage of the students studied 6 hours or more? So here's my 6. So I have this area, and then I have that last area. What percentage do I have from 6 to 6.5? .35, and what about from 6.5 on? .15. Add those up, what do you get for your percentage of the hours studied? .5%. So that is the amount of students that studied 6 hours or more. All right, the running times for a group of 200 runners to complete 1 mile are normally distributed with a mean of 6.5 minutes and a standard deviation of 1.5 minutes. What percentage of these runners can complete this run in less than 3.5 minutes? Draw your line. My mean is 6.5. I have 3 deviations on each side. All right, my standard deviation is 1.5 minutes. Fill out this chart. Alright, so if you guys filled out these numbers, you should have 5, 3.5, and 2. On the other side, you should have 8, 9.5, and 11. They're asking for who can complete this run in less than 3.5 minutes. What do you guys think for this? What percentage? 2.5. This section here is 2.35. This one is 0.15. So it's 2.5% of runners can complete within 3 minutes. That's number 3. The average number of hours that students sleep in a normal distribution with a mean of 7 hours with a standard deviation, mean of 7, standard deviation of 1 hour. 300 students were surveyed. How many students slept between 6 to 9 average on average? 6 to 9 hours on average. All right, when you guys do this, and when you see the words how many, you have to be careful. Because if you write a percentage for how many, it is completely wrong. It is asking you for a certain number, so you have to go further than that. When you see how many, I want you to think about a proportion. So my mean is in the middle, and my mean is 7. And my standard deviation is 1 hour. Okay, so they're asking for how many students slept between 6 and 9 hours. So that would be from here to here. So I have this part, and this part. What is my total percent there? Let me find the percent first. What does each piece equal? Huh? You should get 81.5. This piece is 34, this piece is 34, this piece is 13.5. So you should get 81.5%. That's not our answer though, they're asking for how many, so I need a number. So we're going to make a proportion. Another proportion, I don't know how many kids, out of how many, what's our total amount of students? 300. I know my percent is 81.5 out of 100. So we're going to get a number by cross multiplying. X times 100 is 100x. 300 times 81.5 is 24,450. When you divide by 100, we get x equals 244.5. But because they're asking for how many people, we're not going to have a person. So we're just going to round that up. And say 245 students. If you guys don't practice this on your own while we're doing it, you're going to be super lost on your homework and on your quiz. Don't just wait for me to give you the answer. Or someone else the answer. The average number of points that LeBron James scores in a basketball game is 27 points. With a standard deviation of 8 points. If LeBron plays 82 games in the regular season, and how many games did LeBron James score more than 43 points? My mean is 27. My standard deviation is 8. It's asking me how many games did LeBron score more than 43 points. I have this area and this area. So those two areas together is 2.5%. But they're asking me how many, so I know I need to give a number. Because they said how many games, we have to do a proportion. So my proportion is x over 82, because there's 82 games, and then 2.5 over 100. When you cross multiply, you get 100x is equal to 205. Divide by 100, divide by 100, and x equals 2.05. Because we're rounding, we can say he scored more than 43 points in 2 games. Any questions on those 2 problems? All right, the average age of students in this school is 16 and a half. That's my average, which is right here. With a standard deviation of 0.5. So 1, 2, 3, 1, 2, 3. My deviation is 0.5. It says shade the regions under the curve that represent approximately 81.5% of students. So because we need 81.5% of students, that means I definitely need what's in the inside, because this is the largest at 68. So someone do 81.5 minus 68, what do we have left?
13.5.
All right, so you could choose one of these other sides for 13.5. It doesn't matter which one, because it just said shade approximately 81.5%. Doesn't say high or low. So you can choose 17 to 17.5 or 15 and a half to 16. All right, number 6 says the graph summarizes test scores of 50,000 students. The data is normally distributed with a mean of 81 and a standard deviation of 2.5. Okay, so if you fill that out, you'll get 78.5, 76, 73.5. Go higher, you get 83.5, 86, and 88. They're asking us to shade the region under the curve where the data for approximately 23,750 students are located. Before we can do that, we have to know exactly what that percent is. So we're going to 23,750 divided by 50,000. Type that in, what do you get? You get a decimal. .475. And that as a decimal would be 47.5%. So if I have to shade 47.5%, I know I can't shade the entire middle because that's 68, but I can at least shade 1/2 of it. So Kenzie, what's 47.5 minus 34? All right, 13.5. So that means I can shade one more section of 13.5 because that adds up 34% plus 13.5%. You can shade on either side. It's not telling you which one to use. You can shade this side if you wanted to. It's just saying to show 47.5%.